With so many guys injured, do you think maybe I should suit up for next week's game? Fox, let me put it this way. If you were a fullback, I'd consider it. If you were a halfback, I'd consider it. If you're a quarterback, I'd consider it. Unfortunately, I get it. I'm more like an eighth back. Not quite. A 16th back? A 32nd back? A 64th back? Keep going. Learn anything interesting at school today? Well, I learned our football coach knows scientific notation. Scientific notation going to be extremely helpful with us today as we are going to be practicing the law being Coulomb's law. For each of these, follow the guide steps. Now, number 2 we did in a previous presentation, so you should have an example down here for yourself. I would not set you loose on an activity that I didn't feel you were fully capable of doing. And that is the reason for these guide steps. They actually walk you through how to do the problem. You jot down all the numbers given with those units. That's going to be very helpful for you. And making sketches is going to be an important thing we do in physics. Find out the unknown. Determine what you're looking for. Identify. Okay, figure out the formula, identify the formula, arrange that formula into the variable that you're looking for. For example, in item number 2, we were looking for distance, not the classic what's the force for Coulomb's law format, but we had to rearrange for distance. And then D, do the math. Substitute the numbers and units. Keep the units of the problem for you. It's going to help you and see that you're on the right path. If your units come out, your answer is probably going to be right for your evaluation of these Coulomb's law problems. So take some time, and every single one in the room can start off with the G step. Write down all the given numbers in the problem. There's no reason to sit and stare at a blank page. Just push yourself through each of the steps. Write down the given numbers. Put a question mark and say, all right, what am I looking for? All of these on the page are going to be Coulomb's law problems. So you know you're going to be writing Coulomb's law on every single one of these. And then do the math. You have the formula screaming at you saying, put this number here, put this number here. So do that math. Feel free to use a calculator. And then the E. In the Coulomb's law problems, essentially it's make sure that the units do turn out to be what they need to be as you've gone through and done the math. So you definitely can go through and do many of these steps. Let's see here, 1, 2, 3, 4, 5 of the steps. 3 of them you can do without knowing the math. You just have to find what you're looking for. What do these given numbers mean? So take some time, set up the problems, and then do the math and evaluate your units. This is the first item from the Practice in the Law pages. Each of these we follow the guide steps. These guide steps are here to help walk you through the problem. So the letter G is for the given. You jot down all the given items in the problem. So we have a 1/1000th of a charge, decimal there, and we have a 2,000th of a charge. We have to identify what those quantities are for, and they are for point charges. Coulomb, right here, Coulomb is the SI unit of charge, and the symbol Q is for charge. C is the symbol for Coulomb, which is the SI unit of charge, and the symbol for charge is Q. And it does not matter whether this is Q1 or if this one were Q1. All right, these two charges are 2 meters apart. So 2 meters, that's our distance. You're going to calculate the force between them. So the variable we're looking for is force. And that happens to be the U. That is to determine the unknown quantity you're solving for. And we have that right here with force. The next step in the guide is to identify the formula and rearrange it into the variables that you need. Well, we have Coulomb's law here, and so the formula you're going to use, the electrical force, is Coulomb's constant, Q1 times Q2 divided by the distance squared. Now this formula is in terms of electrical force. I'm looking for the force between these two charges. So I can go ahead now to the D. I can do the math. I substitute the numbers and the variables, and the units with the variables rather. So for this next step, my electrical force equal to, and I always, for I don't know whatever reason, put the K value as the last number that I work through in solving with these problems. So Q1, Q2. So I have 0.001 Coulomb multiplied by 2 coulombs, because I have this charge right there and this charge right there. Then I divide by the distance squared. So divide distance squared, and the distance is here. The distance being 2 meters, and I have to square that. I'm going to copy down my work, and again, K value I'll put in last. So what I'm going to do now is multiply these two numbers. If I put those into a scientific calculator, it's going to tell me the answer is 2 times 10 to the negative 6. Now because I have a Coulomb times a Coulomb, my units are going to be coulombs squared. Now I'm going to do the division by simply at this point writing the division step down. And then I've got to square that 2 meters. So 2 times 2 is 4, and I square the units. A meter times a meter is meters squared. My next step down here, electrical force, the K value. And what I'm going to do now is this division step. How many 4 meters squared go into the 2 times 10 to the negative 6? So if you still have in your calculator the 2 times 10 to the negative 6, you can press divide by 4. And that will be 5 times 10 to the negative 7 coulombs squared divided by meters squared. This right here comes from Coulomb squared divided by meters squared. So whatever I do to the numbers, I do to the quantities as well. So now the K value time. Electrical force is equal to 9 times 10 to the 9th. And remember, you don't have to memorize this number. The units will be provided for you. And it's Newton meters squared per Coulomb squared. So this value right here, I've just substituted the K value, and this number is on a reference sheet. It's on page 0 of your study guide, and it'll be given to you for the CK. Now I need to have this number to multiply. So I'm just going to put a parenthesis here. 5 times 10 to the negative 7 coulombs squared per meters squared. So I slid this up to give myself a little bit more workspace. Now what I'll be doing is this number multiplied by that number. Alright, so I probably already have this number in the calculator, so I can just multiply by that. So times 9 to the 9th, and that gives me an answer of electrical force 4,500. Now for my units, we see that I have a meters squared on top, meters squared on bottom, so they can disappear. Coulomb squared on bottom, Coulomb squared on top, they disappear. So what I'm left with is right here, the newtons. And my SI unit of force should be in the term of newtons. Now, certainly with our Coulomb's law problems, because we're dealing with electrical charges, it's not as easy to go through and evaluate to make sure that the units and the answer are reasonable. We can certainly, like we just did, make sure the units work out, so the math of the units work out to be correct, and that, yes, a newton should be with electrical force, and that should give us the confidence that our numerical math was done correctly as well. You do not need to put this into scientific notation. You would not need to come through and say 4.5 times 10 to the squared. 1, 2, whoops, cubed. You do not need to do that step. We've been writing numbers in thousands of places here all trimester long, so that would be just fine. So there you have it for the number 1 on the practice in the law. Practice in the law, item 3. Two particles are each given a charge of 5 times 10 to the negative 5th. So the guide step here, G, is to jot down the given items and their quantities. So 5 times 10 to the negative 5th coulombs. And notice that that's 2 particles right there. So this will be Q1. It will also be Q2. All right, what is the force? That's what we're being asked. What is the force between the charged particles if the distance between them is 2 meters? All right, so 2 meters is our distance. In the guide step process, the U, identify the unknown, what you're looking for. We've done that there. The I is to identify the formula that's going to best be used. And of course, Coulomb's law. So we'll keep plugging along with electrical force directly related to the Coulomb's value, Coulomb's constant. Q1 times Q2 divided by the distance squared. With our guide steps, the D, do the math. Put the substitutions of the numbers in for the variables. So that's the step that we will do next. Okay, so electrical force, what we're looking for. I do the K value last. I have Q1 times Q2, so I have 5 times 10 to the negative 5th coulombs, and I'm squaring that. This will be divided by the distance squared, the distance of 2 meters squared. The next step of doing the math is to take a look here and power. We're going to go and square this. So let's do that. Electrical force, K value. All right, so 5 squared is 25 times 10 to the, well, when I square exponents, this is from your Know Your Notation page at the end of the study guide, we're going to add those. So a negative 5 plus a negative 5 is negative 10. And the unit of coulombs will be squared as well. This is going to be divided by the 2 meters squared. 2 times 2 is 4. Meter times a meter is meters squared. My next step is to take and do the division right here. How many 4s will evenly go into that 25? So electrical force, K value. So I have 25, whoops, turn the calculator on, 25 to the negative 10. And that will be divided by 4. Divide by 4. My calculator spits out that that is 6.25, wow, quite the decimal, times 10 to the negative 10 coulombs squared per meter squared. Remember, what you do to the numbers, you also do to the quantities, the units right there. and that's a squared possibly. The next step I'm going to do is to write in the K value so that I can multiply those two values. So I'm going to slide this up a little bit. K value isn't in the problem, so we assume it's the one that will be given on your reference sheet. So I'm going to add in the K value. Electrical force. K value is 9 times 10 to the 9th newtons meters squared per coulomb squared. That's not a number you need to memorize. It'll be given to you. Multiply by, and I'm just bringing this information down. 6.25 times 10 to the negative 10 coulomb squared per meter squared. So what I do next is multiply this number by that number, these units by those units. So in doing that, the electrical force, 9 times the 6 and 2500ths, or I can just go ahead and multiply the whole thing on the calculator. So I'll just say times 9 to the, and it's 9th, enter, and that tells me 5.625 times, no tens, nope, that's just the answer right there. The meters squared cancel, the coulomb square cancel, and so that ends up with newtons. Just like the previous problem, we definitely do want this to be in newtons. Now we have 3 decimal places here. Let's take a look up here. The least amount of decimal places we have here is actually none. So in our answer here, go back down, our answer here shouldn't have any decimal places. With that being said, we do have a 6 that's above a 5, so the electrical force would be 6 newtons.